Okay, so weather, erosion, and climate. So the most important thing with regards to climate is, with regards to erosion, is the rate of weathering. Okay, if it is a warm climate or if it is a wet climate, these climates will experience erosion at a more rapid pace. So with different climates come different shapes of the topography. And that's an important understanding. Okay, you have to understand that if there's one climate that's dry, it will have a certain look to it, whereas a wet climate will have a different look to it. And you need to be able to discern or figure out or tell the difference between the two. So climates that are in the extremes are most of the time very small amounts of weathering and erosion occur, such as like the Sahara Desert and Egypt. Okay, these are both hot and dry most of the time. So there's not a lot of change in the weathering conditions. It just stays hot and it stays dry, and there's no chemical action. There's no physical, or there's not a lot of physical weathering unless it's from wind. So there's a very minimal amount of weathering. Okay, and so you need to know hot and dry climates have very little weathering. Okay, same thing for frozen or cold climates. If it's frozen all the time, there's really no change. It's only when you alternate between hot and cold or between dry and wet that you see a lot of weathering happen. So here's a picture of a sand dune in Mauritius, or I should say not Mauritius, Mauritania, and dry climate. Okay, these would be the dry valleys of Antarctica. Very, very dry. Some moisture gets down and forms these dry streams here, but they're, again, cold all the time, not a lot of weather. Whereas if we take a look at the environment where it is, or alternates between cold and warm and dry and wet, you begin to get a characteristic of a different type of, or shape of land. Okay, in the note sheets on 7.2, you'll find that the diagram on the left-hand side is on the back of the side. The diagram on the left, which you're going to have to draw, okay, will be one which we will identify as oops, there we go, okay, as a wet climate. So in a wet climate, we have a round, smooth slope, regardless of rock type, and you have a nice smooth profile. The cloud is there to represent a wet climate. Whereas in an arid climate, you're going to have steep cliffs, and it's going to be jagged. And the jaggedness is it's sharp, angular slope, and the layers that stick out the most, in this case, will be the most resistant to erosion. But the layers of the same rock, okay, and again, sharp, angular slope. Okay, in a dry climate versus a smooth, rounded slope in a wet climate. Okay. Mass wasting. Mass wasting is basically landslides under the force of gravity. Okay. There's different types of mass wasting. Okay. Rock falls or avalanches are the fastest, and they get progressively slower. And these are already labeled out on your note sheet. Okay. So you go from the fastest. And this is basically the difference between a rock fall and a rock slide is there's air time with the rock fall. Will you ever be tested on it? Probably not. You just need to know that all of this is movement under the force of gravity. Gravity is pulling this stuff down, and it's moving. The ones that happen in and around New York State are these two, slump and creep. Creep happens very, very slow over years. Slump happens over months. There's a big giant slump or landslide out in Washington State earlier last year. That was a big, massive movement of earth, and it came down on a housing tract out in Washington State. Big tragedy, but it was a form of mass wasting. So, landslide or slump. This would be a mud flow, and there's the bulldozers that give you a perspective of how big the mud flow is across the highway. And I'm going to go back to dry versus arid landscapes, just really quickly. So this would be Scotland. It's a wet landscape. There is some jagged to the top, but for the most part, it's rounded cliffs. It's smooth. Rock layers are really, really tough rock in Scotland, but it doesn't matter. The water has smoothed it, so it is a very round surface. Okay. Whereas this is Monument Valley on the border of Arizona and Utah, and you have very steep profiles, okay, very delineated, okay, because it's a dry climate. And these are, again, mesas and buttes in Monument Valley. So really quickly, we did a lab with porosity and permeability. Some of you weren't here in attendance, but I did it with the tubes on Thursday last week. Okay, permeability is the speed at which water flows through. Small materials have a low permeability. Large materials that are sorted have a high permeability. The water flows through quickly. And those that are mixed have a low permeability. Okay? Porosity is the amount of pore space, or the open area in between the particles. And if it's well sorted, all of the material, which is small, but it's all the same size, and the same thing for beads of the same size but large, the small spaces equal single big spaces, and these have equal porosities, okay? They're both about 44% porosity, whereas if you mix them up, your porosity drops. So it's not a question of the size of the beads, but the mixture of the beads. If it's mixed, it's low porosity or open pore space in between the beads, whereas high porosity is when you have well-sorted material. Okay, water retention. Not on this page, but still something to go over. You have high water retention on small materials because of lots of surface area. Low water retention on big materials because they don't have a lot of surface area. Okay? That should help you out with your worksheet, Porosity and Permeability 1, which I will be checking on Thursday. And thank you for watching the video.